The benzene diazonium salt or aromatic diazonium salts are more stable because they have resonance which is happening. The nitrous acid is produced in the reaction mixture by the reaction of sodium nitrate with hydrochloric acid. So this part you can see, that is how we are preparing nitrous acid in situ. Benzene diazonium chloride is a colorless crystalline solid. It is readily soluble in water and is stable in cold but reacts with water when warmed. Hello everyone, this is Ambli Unnikrishnan from the Department of Chemistry. So today I am back with the last session of the chapter Amines. So in the last session we have discussed the various chemical properties or chemical reactions of amines, wherein we discussed acylation, carbylamine reaction, reaction with nitrous acid, reaction with benzene sulfonyl chloride, that is Hinsberg's reagent, and electrophilic aromatic substitution reaction, in which we discussed bromination, nitration and sulfonation. So in today's session we are going to study about the next important topic, that is diazonium salts. So you have already studied what is diazotization reaction, and in diazotization reaction you will be getting diazonium salt. So regarding that, the method of preparation, the physical and chemical properties of that we are going to discuss in this session. Right. So the organic compounds with the general formula Rn2 plus X minus are called as diazonium salt. So this X you can see, they are halogens. So it can be, for example, Rn2 plus Cl minus. So this is benzene diazonium salt, right? So it is called as benzene diazonium salt when this R group is going to be benzene or the benzyl group, right? So this is called as a diazonium salt in general when the R group can be any alkyl or aryl group. Clear? So here the diazo group is actually a triple bond and Cl minus. So this N2 I have written, it is N triple bond N. That is why it is called as diazo. Clear? Now, they are named by suffixing diazonium to the name of the parent hydrocarbon from which they are formed. Okay. So, it is suffixed by diazonium. For example, this R group, if it is benzene, we call it as benzene diazonium salt. Okay. So, the parent hydrocarbon, whichever it is, that name we have to use, benzene and diazonium salt. So, the benzene you have to use and you have to suffix it with diazonium. That's it. Okay. Now, the primary aliphatic amines form highly unstable alkyl diazonium salt. Primary aromatic compounds form benzene diazonium salt, which are stable for a short time in solution at low temperature. The stability of benzene diazonium salt is explained on the basis of resonance. So, if the R group present here is an alkyl group, you will get alkyl diazonium salt. They are generally unstable. But the benzene diazonium salt or aromatic diazonium salts are more stable because they have resonance which is happening. So we know that more the resonating structures, more will be the stability. But in alkyl diazonium salt, as it is not possible, they are not stable. But because of resonance, in benzene or aryl diazonium salt, they are more stable because of the resonance. So this is the resonating structure. Now moving on to the methods of preparation of diazonium salt. Diazonium salts were first obtained from aromatic amines in 1858, and their utility in the preparation of azo compounds was soon recognized by the dye industry. So there is a reaction called as coupling reaction, which we are going to study now. So in that we are preparing dyes. The colored dyes that you can see, that is based on this benzene diazonium salt. Okay. Now, benzene diazonium chloride is prepared by the reaction of aniline with nitrous acid at 273 to 278 Kelvin. Okay. So, the reactant here is aniline. It reacts with nitrous acid, that is NaNO2 and HCl. In situ, it can be prepared from NaNO2 and HCl, that is nitrous acid at 273 through 278 Kelvin will give you what? Benzene diazonium chloride, that is C6H5N2Cl. Okay. So, you will get the benzene diazonium chloride, right. So, N2 plus and Cl minus will be the charge which is present here. Now, the nitrous acid is produced in the reaction mixture by the reaction of sodium nitrate with hydrochloric acid. So, this part you can see, that is how we are preparing nitrous acid in situ. Now, the conversion of primary aromatic amines into diazonium salt is known as diazotization. Due to its instability, the diazonium salt is not generally stored and it is used immediately after its preparation. Okay, so aniline reacts with nitrous acid, which is prepared from sodium nitrite and HCl, and it forms benzene diazonium salt, sodium chloride and water. So this formed benzene diazonium salt. So the benzene diazonium salt which is formed, they are generally unstable. So immediately they are used for the further preparations or further reactions. So now let's see here. This is aniline and reacts with NaNO2 and HX. HX stands for, it can be HS, HCl, HBr, any mineral acid. Okay. So now what happens, which X we have taken there, based on that you are going to get the benzene diazonium salt. Okay. So if you are taking Cl here, that is chlorine here, you will get benzene diazonium chloride. Okay. So here it is benzene diazonium salt, it can be any X, it can be chlorine, bromine or iodine. Okay. So you will get the benzene diazonium salt, sodium halide, whichever halogen you are using, and water. So this is the method of preparation of diazonium salt. Right. Now let's move on to the physical properties. Benzene diazonium chloride is a colorless crystalline solid. Benzene diazonium chloride we are talking about, that is C6H5N2 plus Cl minus. The halogen we are using here is chloride. It is readily soluble in water. It decomposes easily in the dry state. Benzene diazonium chloride is a colorless crystalline solid. It is readily soluble in water and is stable in cold but reacts with water when warmed. It decomposes easily in the dry state. Benzene diazonium fluoroborate is water insoluble and stable at room temperature. So these are the few physical properties of benzene diazonium salt. Now moving on to the chemical reactions which are important. So the chemical reactions of diazonium salts, it is majorly divided into two categories. First one is reactions involving displacement of nitrogen. So you have nitrogen in the benzene diazonium salt, right? N2Cl. So the displacement of nitrogen. Another one is reaction involving the retention of diazo group. That means there is no reactions or no change in the N2 group. Okay. One is wherein the nitrogen bond is going to break. Another set of reactions in which the N2 will remain as it is. So first let us begin with the reactions involving displacement of nitrogen. So the replacement by halide or cyanide ion. Okay. So in place of nitrogen, what is going to get replaced? Halide or cyanide ion. The Cl minus, Br minus and Cn minus, that is chloride ion, bromide ion or Cn minus, cyanide ion nucleophiles can easily be introduced in the benzene ring in the presence of copper ion. This reaction is called as Sand-Meyer reaction. So it's a name reaction, that is wherein the nitrogen is going to be displaced or removed as nitrogen gas and the halogen or the cyanide ion is going to be replaced. So let us see here, ArN2 plus X minus. This stands for benzene diazonium salt. That is Ar stands for the aryl group, right? And then you have N2 plus and X minus. So this X can be chloride, bromide or ionide. So this happens in presence of Cu2Cl2, cuprous chloride, and in presence of any mineral acid, HCl. So we have taken HCl here. So what is going to be substituted here? Chloride ion is going to be substituted. So what is going to be happening is this aryl group will remain and this nitrogen is going to be displaced as nitrogen gas. Right. And what is going to be substituted here? The chloride is going to be substituted here. So you will get ArCl. What is ArCl? It is chlorobenzene, right? So instead of this N2X minus, what you are going to get? The chlorine is going to get substituted there. Now, in presence of Cu2Br2 and HBr, what is going to be substituted? Bromine is going to be substituted, right? So same way you will get ArBr, that is bromobenzene, and nitrogen gas will be liberated by the displacement of nitrogen. And if you are using CuCN and KCN, in presence of KCN, what is going to be substituted? Cyanide ion is going to be substituted. You are going to get ArCN, that is cyanobenzene. Again, nitrogen gas will be liberated. Clear? Now, alternatively, chlorine or bromine can be introduced in the benzene ring by treating the diazonium salt solution with corresponding halogen acid in the presence of copper powder. This is referred to as Gattermann reaction. Okay, so this particular reaction is called as Sand-Meyer reaction. Now, in another way also, you can produce chlorobenzene or bromobenzene by the reaction of benzene diazonium salt with the corresponding mineral acid. Corresponding mineral acid means if you require chlorobenzene, you use HCl. If you require bromobenzene, you use HBr. So you can see here benzene diazonium salt, it reacts with copper powder. Okay, this is cuprous chloride or cuprous bromide we are using. Here it is copper powder. In presence of HCl, what is going to happen? Chlorine is going to get substituted. Here you will get chlorobenzene. Again, nitrogen gas will be liberated and you will get the copper corresponding halide you will get. And same way, if it is copper in presence of HBr, you are going to get bromobenzene and nitrogen gas will be liberated. Okay, so I hope this is called as a Sandmeyer reaction and this is the Gattermann reaction. Either of these can be used for the preparation of chloro and bromobenzene. Moving on to the next one, that is replacement by iodide ion. Okay, we are going to replace by iodide ion. Iodine is not easily introduced into the benzene ring directly, but when the diazonium salt solution is treated with potassium iodide, iodobenzene is formed. Okay, so these two methods that we have discussed, it is just for chlorobenzene or bromobenzene to form. Here, if you require iodine to be substituted, you have to use potassium iodide. So, benzene diazonium salt in presence of potassium iodide, you are going to get iodobenzene, KCl, and again nitrogen gas will be liberated. Now, replacement by fluoride ion. So, when arene diazonium chloride is treated with fluoroboric acid, arene diazonium fluoroborate is precipitated, which on heating decomposes to form aryl fluoride. So, benzene diazonium salt is going to react with fluoroboric acid, which is HBF4, and what you are going to get first? Arene diazonium fluoroborate will be formed. Fluoroborate will be formed. So that means here we are using HBF4, right? So what is going to happen? BF4 minus and N2 plus will be formed. Instead of Cl minus or Br minus or I minus, what is going to be formed here? BF4 minus will be formed. Now on further heating, what you are going to get? Fluorobenzene will be obtained, BF3, and again nitrogen gas will be liberated. Now moving on to the replacement by hydrogen. Certain mild reducing agents like hypophosphorus acid or ethanol reduce diazonium salt to arenes and then they themselves get oxidized to phosphorus acid and ethanol respectively. So you have the benzene diazonium chloride. It's going to react with hypophosphorus acid. H3PO2 is called as hypophosphorus acid. In presence of water, it undergoes hydrolysis. What is going to happen? H is going to be substituted. So, H is going to be substituted means what is going to happen? You will just get the benzene, right? Instead of N2Cl, it is going to be H means you get the benzene. So, benzene is obtained, again nitrogen gas is liberated. You are going to get phosphorus acid and HCl. Same way, benzene diazonium chloride can react with ethanol again to form benzene. Nitrogen gas is liberated. You have ethanol and HCl. Okay, so these two reactions can be used to prepare benzene. From benzene diazonium chloride, how you can prepare benzene, these two reactions you can use. Now you have the next reaction, that is replacement by hydroxyl group. That is, we are going to replace it by OH. If the temperature of the diazonium salt solution is allowed to rise up to 283 Kelvin, the salt gets hydrolyzed to phenol. So, this is a method in which you can prepare phenol. Benzene diazonium chloride reacts with water, that is, it undergoes hydrolysis. What is going to happen? In water, the OH is going to be substituted here. So, what you are going to obtain? Phenol. AROH means what? AR means your benzyl group, and in here OH will be substituted, that is phenol. Nitrogen gas will be liberated as well as HCl will be obtained. Now moving on to replacement by nitro group, NO2 group. When diazonium fluoroborate is heated with aqueous sodium nitrite solution, in the presence of copper, the diazonium group is replaced by nitro group. So let's see the reaction here. Benzene diazonium chloride, it reacts with fluoroboric acid. What you are going to get? You are going to get fluoroborate. Right. Now that is N2 plus BF4 minus. Now it is going to react with NaNO2, sodium nitrite and copper, and when we are heating it, what you are going to get? The nitro group in NaNO2 is going to be substituted here, and nitrogen gas again will be liberated with NaBF4. So this is the reaction involved when you have to obtain nitrobenzene. Now moving on to the reactions involving retention of diazo group. There is no displacement of nitrogen happening here. So the important reaction is called as coupling reaction, which is important in the dye industry as well. Benzene diazonium chloride reacts with phenol, in which the phenol molecules at its para position is coupled with the diazonium salt to form para-hydroxy azobenzene. This type of reaction is known as coupling reaction, and these compounds are often colored and are used as dyes. So this is how dyes are prepared, that is using coupling reaction. So what is that you are taking here? Benzene diazonium chloride is taken, and in presence of aniline. Okay, aniline you can see here benzene and NH2. This is the hydrogen present in the ring itself. So this is benzene diazonium chloride reacting with aniline in presence of OH minus. What is going to happen? Again HCl is going to be removed. removed. Okay, HCl is going to be removed. Now these two are going to combine. So what you are getting? A nitrogen double bond will be formed here and OH will be here. That is, from this side it is going to be substituted. Okay, so now what will be removed? Water will be removed. So this is how para-amino azobenzene is formed, that is your dye is formed. You can see here it's a yellow color dye which is formed. So this is the coupling reaction. So now moving on to the importance of diazonium salts in the synthesis of aromatic compounds. So the replacement of diazo group by other groups is helpful in preparing those substituted aromatic compounds which cannot be prepared by direct substitution in benzene or substituted benzene. Aryl fluorides and iodides cannot be prepared by direct halogenation. So by direct halogenation, we cannot prepare aryl fluorides or iodides. They can be prepared using benzene diazonium salt. We have already studied those reactions wherein you can obtain iodobenzene and fluorobenzene. They are generally very highly reactive, so they can't be prepared directly by adding iodine or fluoride. So the best method is through benzene diazonium chloride. The cyano group cannot be introduced by nucleophilic substitution reaction of chlorine in chlorobenzene, but cyanobenzene can be easily obtained from diazonium salt. So cyanobenzene, iodobenzene and fluorobenzene can be easily produced through the benzene diazonium salt rather than direct addition of the cyano group or halogenation. So I hope the importance of benzene diazonium chloride is also clear. So by this we come to an end to this chapter, that is amines. So I hope the concepts that I have covered in this session is clear for you. So in the next session, let's meet with a new chapter. So that's all for today. Thank you.